Hello there and welcome back to the Sleep Science. Tonight you find yourself gliding on the edge of darkness. Where the night sky is no longer a flat black dome, but a swirling river of light stretching from one horizon to the other. The Milky Way arches overhead like spilled silver dust, luminous and fragile, yet also impossibly vast. Your eyes can barely begin to trace its shape. You tilt your head, trying to follow the curve, but every speck of light you lock onto only reveals 10 more hiding behind it. You probably won't survive this attempt to count them all. Seriously, you'd give up before breakfast. But that's the charm. The galaxy is bigger than your imagination has room for. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, if you're feeling friendly, drop your location and your local time in the comments. Kind of fun to see where this late-night galaxy crew is watching from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're standing at the edge of one of the galaxy's spiral arms, or at least imagining it, looking outward at the glowing ribbon that curls like a cosmic whirlpool. The Milky Way is a barred spiral galaxy, which means instead of being a neat pinwheel, it has a chunky bar of stars through the centre, with great arms unfurling outward. Those arms are where much of the action happens, nebulae lighting up like neon signs, baby stars bursting into existence, and dark rivers of dust slicing across the view like black velvet. If you could hover here without worrying about pesky details like oxygen, you'd see that what looks to your eyes like a milky band is actually billions upon billions of suns, most so faint and distant that your brain stitches them into one glowing smear. Now here's a fun little fact you can smugly drop into your next trivia night. The Milky Way isn't named for chocolate bars or breakfast cereal, tempting as that thought is. The name comes from the ancient Greek galaxias kyklos, meaning milky circle. To them, it looked like the gods had spilled milk across the heavens. Historians still argue whether the myth of Hera breastfeeding Heracles, yes, divine spillage, was inspired by the band in the sky, or if that story came later to explain the name. Either way, the branding stuck. Imagine explaining to future civilizations, our galaxy is named after a messy snack time. You stretch your vision across the spiral arms, and they seem endless. Astronomers today know that the Milky Way stretches at least 100,000 light years across, maybe as much as 200,000, depending on how you define its edges. To put that in human terms, if you fired up a spaceship that could travel at the speed of light, good luck affording the fuel, it would still take you 100,000 years just to cross the disk. For reference, modern humans have only been around for about 300,000 years, so by the time your ship reached the other side, your entire species might have redesigned fashion 300 times. Looking back, it's kind of wild how long it took humanity to figure out just how big this thing is. For most of recorded history, people assumed the Milky Way was just some local decoration, maybe nearby stars, maybe a band of clouds, maybe the heavens themselves cracking open. Aristotle suggested it was the result of stars burning in the upper atmosphere, which sounds like a fancy way of describing glow-in-the-dark stickers on the ceiling. The ancient Chinese described it as the Silver River, and woven into their folklore was the story of a cowherd and a weaver girl separated across its celestial waters. Even without telescopes, cultures sensed this band was more than an accident of nature. It carried the weight of a cosmic divide. But here's the kicker. You can only see the Milky Way clearly from dark skies. City dwellers might think it's a myth at this point, drowned out by the blaze of streetlights and glowing billboards. Step out into the countryside on a moonless night though, and you'll see it in all its glory. It's like the universe finally remembers to dim the stage lights and let the backdrop show. The first time you really see it. Your brain might short-circuit a little. One traveller in the 19th century described the view as a great highway of worlds stretching across the firmament. Let's sneak in another quirky tidbit while you drift here. In medieval Europe, people thought the Milky Way was literally the path the souls of the righteous followed into heaven. So not only was it a stellar spectacle, it was also basically an intergalactic Uber route. In some traditions, the band even guided migrating birds, as if the geese were carrying their own star maps. Today, we know birds do use the stars for navigation, though whether they specifically key in on the Milky Way is still debate. Imagine being a goose and treating a galaxy as your road sign. Talk about high standards. Now floating where you are, you feel the immensity pressing in from all sides. The spiral arms don't end in tidy edges. They blur into faint stars, then into gas clouds, and eventually into the halo, a faint sphere of ancient stars surrounding everything like a ghostly bubble. That's when the sense of scale really lands. You're not looking at a flat pancake with arms, you're inside a three-dimensional swarm stretching farther than the mind wants to measure. Astronomers still argue whether the halo is a distinct structure, or just a fading population of stars. Either way, it means the Milky Way is a lot puffier than most of us picture. You reach your hand out, pretending you can touch the starlight, and if you could, your fingers would brush against light that left its source tens of thousands of years ago. You're not seeing the galaxy as it is now. You're seeing it as it was when woolly mammoths still walked the Earth. That's another casual mind-bender. Stargazing is always time travel. Every point of light is an ancient message finally arriving like cosmic snail mail. You half expect some of the stars to apologize for being late. And here's your final fun reality check for this section. Everything you see in that bright band, the entire Milky Way galaxy, is just one of maybe 2 trillion galaxies in the observable universe. So yes, the galaxy feels impossibly huge, but it's also just one grain of sand on an infinite beach. That's humbling, terrifying, and oddly comforting all at once. As you keep drifting along the spiral arms, the starlight thickens into dazzling rivers. You realize that even if you spent the rest of your life counting, you'd never get close to finishing. And maybe that's okay. The point isn't to measure it with your fingers, it's to let your imagination stretch wider than it usually does. To float here, weightless and quiet, and admit you're part of something enormous. You keep drifting, your gaze glued to that glittering haze overhead, and the thought hits you. Somebody had to be the first to start counting. Not you, thankfully, but long before telescopes, ancient sky watchers sat out under dark horizons and decided the Milky Way must be made up of individual points of light. With no calculator apps, no spreadsheets, just human soul eyes and an awful lot of patience, they tried to tally the untallyable. You picture an early Babylonian priest with a reed stylus, scratching down dots on clay tablets, trying not to lose his place, muttering the ancient equivalent of, "Wait, did I already count that one?" The attempt was doomed, of course, but the effort mattered. It planted the idea that this band could be broken down star by star. The earliest star counts weren't just idle curiosity. They were woven into calendars and rituals. In Mesopotamia, priests aligned temples with bright stars, believing their positions marked the moods of gods. By comparing the density of stars across the sky, they guessed at the heaven's shape, though the Milky Way itself was more of a mystery. Historians still argue whether these cultures thought the Milky Way was a road of souls, a tear in the sky fabric, or simply a dense cluster of stars invisible to individual counting. Whatever their conclusion, you can imagine them hunched over their observations, inventing math as they went, their world expanding one scratch mark at a time. Centuries later, Greek philosophers tried their own versions of this cosmic census. Democritus, the guy who first proposed atoms, casually suggested that the Milky Way was nothing more than a multitude of small stars. He couldn't prove it, but hey, points for intuition. Aristotle disagreed and insisted it was a kind of atmospheric phenomenon, like celestial weather. He probably wouldn't love knowing his big idea aged about as well as a floppy disk. Still, these attempts show how obsessed people were with fitting this streak of light into a tidy explanation. And then there were the poets. The Roman writer Manilius called the Milky Way a shining girdle, holding the sky together, which sounds more like cosmic fashion commentary than science. Yet for all the flowery descriptions, even they couldn't resist trying to count. With no telescopes, they may have used tally sticks or simply recorded their guesses in verse. You imagine them craning their necks, stubbornly refusing to admit the futility. Counting stars by eye is like trying to number the grains of sugar in your tea. You'll go cross-eyed before you get close. The medieval Islamic world took star cataloguing to another level. Astronomers like Al-Sufi carefully mapped hundreds of stars, noting brightness and name, S, and position. And some of his manuscripts even depicted the Milky Way as clusters within clusters. These scholars worked with the astrolabes, not iPads, yet their star charts became astonishingly precise. One quirky tidbit: some records suggest early observers described the Milky Way as looking smoky, almost like a cosmic bonfire. Historians still argue whether that was poetic license or an earnest attempt to capture what dust and unresolved starlight look like to the naked eye. Either way, it shows the same restless need to describe what they were seeing, even if words and numbers always fell short. By the Renaissance, the tally game got more sophisticated, though still hilariously impractical. Tycho Brahe, the flamboyant Danish noble with a brass nose, yes, he lost the original in a duel, spent countless nights cataloguing stars by hand. He ended up with thousands on his lists, not millions, and certainly not billions, but every entry was another piece in the puzzle. Imagine the dedication. Standing out in freezing weather, dressed in ruffles, nose glued to the heavens, muttering about magnitudes, it's like extreme stargazing cosplay. Yet Tycho's meticulous counts gave later astronomers data to chew on, even if he was far from cracking the Milky Way's full scale. Meanwhile, outside Europe, the Inca and other Andean peoples weren't counting stars as much as they were reading the dark gaps between them. Instead of constellations of bright dots, they traced llamas, serpents, and foxes in the inky voids within the Milky Way's glow. To them, those shapes were living beings influencing crops and seasons. Here's the quirky twist. Their system actually gave them a practical calendar tied to animal behaviour, more useful than a futile attempt to number every pinprick. It's a reminder that counting wasn't always about digits, it was also about meaning. And you, floating here in imagination, realize that every culture took its turn at this impossible census. Some counted stars like accountants with no end of ledgers. Others wrapped mythology around the sky, using numbers as decoration for stories. The universal thing, though, was the urge to quantify, to shrink this incomprehensible sprawl into something human-sized. That's comforting in a way. You're not the first person to stand under the Milky Way and think, how many are there? Can I figure this out? The answer has always been no, but the act of trying brings you closer to the cosmos. As you continue to drift, the futility becomes part of the charm. You could keep counting, whispering 1, 2, 3, until your voice gives out. You'd never finish, but you'd feel the scale pressing down on you like measuring the ocean with a teaspoon. Maybe that's why those ancient astronomers did it. Not because they thought they could succeed, but because the effort itself made them part of the mystery. Counting stars by candlelight was less about the total and more about acknowledging the galaxy's immensity. And in that sense, they weren't wrong. They were just trying to turn infinity into bedtime math. You're still gliding through that milky band, the stars packed so tightly that they blur into a silver mist. It's a little hypnotic, and you can understand why ancient Greek philosophers spent so much time staring at it. To them, this glowing streak wasn't just decoration, it demanded explanation. Some called it spilled milk, others thought it was celestial fire, and still others argued over whether it was dust, stars, or some kind of cosmic accident. The debate was less about astronomy and more about philosophy, with each thinker trying to slot the Milky Way neatly into their version of the universe. Aristotle, never shy about having an opinion, insisted the glow wasn't even in space at all. He thought the Milky Way came from friction in the upper atmosphere, as though the heavens were rubbing together and producing sparks. You can imagine him pointing at the sky, convinced he had cracked it, while students dutifully nodded along. Historians still argue whether Aristotle genuinely believed in this celestial fire explanation, or whether he was borrowing from older traditions. Either way, it's a little humbling to realize that one of history's great minds basically thought the galaxy was atmospheric static. Meanwhile, other Greek thinkers had different takes. Democritus, the same guy who first suggested atoms, proposed that the Milky Way was simply a mass of distant stars. He didn't have the technology to prove it, but you've got to give him credit for intuition. Then there was Pythagoras, yes, the triangles guy, whose followers believed the Milky Way was the path of the gods, maybe even the road souls travelled after death. Imagine walking outside, pointing at the night sky and casually telling your neighbour, that glowing band, that's basically the divine highway system. The Romans, never ones to skip a mythological remix, spun their own version. In one story, Hera spilled her milk while nursing the baby Heracles, and the white spray stretched across the heavens. That cosmic spill became the Galacticos Kyklos, or Milky Circle. Fast forward through some Latin wordplay, and eventually English speakers ended up calling it the Milky Way. Not exactly flattering, is it? Out of all the possible names for our home galaxy, something grand, something mysterious, we got spilled milk. Somewhere the Andromeda Galaxy is laughing at us. But here's the quirky part. The Greeks weren't entirely wrong to think of the Milky Way as dust. When you look up with your naked eye, what you're seeing really does resemble faint smoke or a powdery trail. In fact, medieval Arabic texts often described it as al-laban al-masluk, which can translate to the poured milk or sometimes a path of dust. The line between metaphor and science blurred, and every culture leaned into whichever description fit their worldview. To the Maya, for instance, it was a cosmic river, and their mythology used it as the stage for gods and monsters. The idea that it might be stars was there in whispers, but the poetry usually won. And that raises the real question. Did early people even want a scientific answer? You stand here in your imaginary space bubble, watching the band curl across the void, and you wonder. The Milky Way isn't just a scientific object, it's also a source of stories, navigation, even romance. The Greeks told tales of rivers separated by the galaxy's stream. The Chinese saw it as the Silver River, keeping the cowherd and the weaver girl apart except once a year, when magpies built them a bridge of wings. These myths weren't wrong, they were another way of interpreting the same glow. Historians still argue whether we should call such ideas proto-science or simply mythology. Maybe the line doesn't matter. Still, curiosity has a way of creeping back in. Some ancient writers described the Milky Way as being made of innumerable small bodies, suggesting they suspected stars but couldn't resolve them. Without telescopes, though, it was like trying to identify grains of sand with your bare eyes. The band stayed stubbornly fuzzy, a riddle with no way forward. If you've ever squinted at a distant streetlight and wondered if it was one bulb or a cluster, you've felt the same frustration. Multiply that by 1 billion, and you're basically an ancient Greek astronomer. Here's a small but delightful fringe tidbit. In some folklore, people thought the Milky Way was actually frost. Yes, frost in the sky. The white streak resembled ice crystals glistening in morning light, so some storytellers decided that must be what it was. Imagine trying to lick the night sky, hoping to taste frozen dew. The image is silly, but it speaks to how people made sense of the heavens by comparison with familiar earthly things. As you drift, you imagine yourself beside one of those early philosophers, both of you staring up and trying to reach agreement. Is it milk, he asks, or dust? You shrug. Or 1 trillion suns? The truth is nobody knew, and nobody could know. Not yet. The Milky Way was simply too vast, too blurred, too stubbornly mysterious for pre-scientific tools. All they had were stories, guesses, and the determination to keep asking. And in that sense, you feel kinship with them. You're still staring at the same streak, still caught between poetry and math, still tempted to call it a river or a path or a scar in the sky. The difference is, you know the answer is waiting just a little further ahead in history, once telescopes come along to sharpen the blur. But for now, you linger in that era of uncertainty, surrounded by philosophers arguing at the edges of knowledge. The Milky Way stretches overhead, vast and unknowable, a riddle wrapped in spilled milk, dust, and divine highway lanes. And in the silence you realize something, sometimes not knowing as its own kind of wonder. The glow above you sharpens as if someone just adjusted the focus knob on reality, and suddenly you're peering through a crude little tube of glass and brass. It's 1609, and Galileo Galilei has just aimed his homemade telescope at the Milky Way. Imagine the scene. A chilly Italian night, Galileo squinting, muttering in Tuscan under his breath, fiddling with a device that magnified the sky only about 20 times. Nothing fancy. By today's standards, it's about the optical power of a cheap pair of binoculars, and yet what he saw through it was enough to knock the wind out of human arrogance. Through the eyepiece, that hazy river of light didn't look smooth anymore. It broke into thousands of pinpoints, stars packed together so tightly that they blurred into mist. For Galileo, this was the smoking gun. The Milky Way wasn't atmospheric smoke, divine milk, or heavenly frost. It was countless stars too faint to see individually with the naked eye. Historians still argue whether Galileo truly understood the scale of what he'd uncovered, but the revelation shattered centuries of guesswork. You're watching as the cosmos for the first time is revealed to be orders of magnitude larger than anyone had dared to imagine. Galileo later published his sketches in Siderius Nuncius, the Starry Messenger, in 1610. The book wasn't long, but it packed a punch. Drawings of craters on the moon, moons orbiting Jupiter, and that bold claim about the Milky Way's starry nature. Picture him holding up those sketches at dinner parties, grinning smugly as philosophers sputtered into their wine. He'd not only challenged Aristotle, He'd pretty much drop-kicked centuries of common sense. It was the cosmic equivalent of showing up with the first smartphone while everyone else still thinks fire is the hottest new thing. But Galileo's discovery didn't immediately convince everyone. Many scholars resisted, arguing that the telescope distorted reality. Some even claimed the tiny stars Galileo saw were artifacts of flawed glass, like specks of dust trapped in the lens. That's the academic version of saying your glasses are dirty, bro. Quirky side note. Galileo's telescope really did have imperfections, blurry edges, chromatic smears, yet what he saw was undeniably real. The galaxy wasn't a smooth band of light. It was a glittering metropolis of stars. You float beside him as he adjusts his telescope again, pointing it toward the Milky Way's densest sections in Sagittarius and Scorpius. Through the lens, he sees more stars than he can count, layered upon layers, a celestial city that stretches into the black. And here's the kicker. Galileo had no way of knowing how far those stars extended. He knew they were countless, but the true breadth of the Milky Way remained hidden. He had just cracked open the door. Behind it was an endless hallway of mysteries. It's almost funny to think about how small Galileo's telescope was compared to what's coming later. Today we have the Hubble Space Telescope and its younger cousin James Webb, peering billions of light years away. Galileo? He was working with a tube smaller than a baseball bat. Yet his courage to simply look, to not take Aristotle's word as gospel, made the difference. Sometimes progress starts with nothing more than squinting through cloudy glass and saying, that doesn't look like what the textbooks say. Here's a fringe tidbit for you. Galileo wasn't the only one experimenting with telescopes around that time. In the Netherlands, spectacle makers like Hans Lippershey had built spyglasses mainly for military use. Sailors and generals used them to spot ships or troops at a distance. Galileo heard about the invention and basically said, "Cool toy, I'll build my own." He refined the design and then had the audacity to point it upward instead of across a battlefield. That single change, aiming the telescope at the heavens instead of the horizon, was revolutionary. Sometimes history pivots not on wars or kings, but on where you point a piece of glass. As you hover in this moment, you realize how radical Galileo's discovery must have felt. Imagine going to bed one night believing the universe is cozy, small, centered on Earth with a neat little hierarchy of heavenly spheres, and then waking up to find that even the faintest streak of light is made of countless suns. It's like opening your closet and discovering it's actually an airport terminal with thousands of people bustling through. No wonder some thinkers resisted. The scale was just too much. Historians still argue whether Galileo himself grasped the Milky Way's true immensity. He knew it was made of stars, yes, but he didn't yet know about the galaxy's shape, its spiral arms, or its staggering size in light years. That understanding would take centuries more and a lot of stubborn observations, but in that moment, with his rickety telescope and his stubborn grin, Galileo had cracked the mystery wide open. The Milky Way wasn't myth, wasn't weather, wasn't frost. It was stars. Endless stars. You linger there beside him, watching his hand tremble slightly as he sketches dots onto parchment. He pauses, looks back through the telescope, then adds more, until the page is crowded. You almost want to whisper to him, "Don't stop. Keep going. You've only scratched the surface." But you don't. You let him discover at his own pace, in his own time, marveling at the first moment humanity realized the galaxy was a swarm of suns. The Milky Way stretches overhead, no longer just a blur. Thanks to Galileo, it has become a cathedral of stars, each one whispering across the darkness. And you, centuries later, are still peering with him, still feeling the shock of that first glimpse through glass. The galaxy has never looked the same since. You drift onward, the stars multiplying around you until they feel like snowflakes in a blizzard. And suddenly you're looking over the shoulder of William Herschel in the late 18th century. He's hunched over a telescope far larger than Galileo's. Herschel wasn't content with dainty spyglasses. He built giants in his backyard, some so unwieldy that using them was basically an extreme sport. Herschel had one goal in mind, to count the stars and map the Milky Way itself. If Galileo cracked open the door, Herschel wanted to walk through it, clipboard in hand, tallying every cosmic resident he could see. His technique was called stargazing. The idea was deceptively simple. Point a telescope at a slice of the sky, count the stars within its field of view, then repeat, again and again in every direction. More stars in one direction meant more galaxy in that direction, fewer stars meant less. By combining all these counts, Herschel hoped to reconstruct the shape of the Milky Way. No small ambition, considering he was basically using the astronomical equivalent of a ruler and guesswork. You picture him and his sister Caroline, bundled against the English chill, working through endless nights. Caroline, by the way, was no assistant in the modern sense. She was an accomplished astronomer herself, discovering comets and compiling meticulous catalogues. Together, they sifted through the heavens, tallying star after star until their records filled thick notebooks. Quirky tidbit: Herschel sometimes described his work as sweeping the heavens, which makes him sound like the universe's janitor. Broom in one hand, telescope in the other. The result of all this counting was the first real map of the Milky Way, published in 1785. Herschel's drawing looked like a rough starry disk, a flat system shaped a bit like a grindstone with the sun plopped right in the centre. And here's the kicker: it wasn't entirely wrong. The Milky Way is a disc-shaped system. Herschel just didn't have the tools to see the full extent, and by assuming all stars were the same brightness, he underestimated distances badly. His galaxy map was lopsided, skewed by dust clouds and his telescope's limitations. Still, for the first time, humanity had tried to draw the galaxy as an object, not just admire it as a band of light. Historians still argue whether Herschel truly believed his map was definitive or if he saw it as a work in progress. What's certain is that the sketch electrified his peers. Here was a vision of the Milky Way as something tangible, structured, measurable. Not a myth, not a streak of milk, but a system with edges. Of course, but the irony is that his galaxy was far too small. Herschel thought the Milky Way was about 15,000 light-years across. Tiny compared to modern estimates of 100,000 to 200,000. But still, imagine being the first person to say, "Here's the shape of our stellar city." Even if your proportions are off, it's like drawing the first map of Earth's continents. Lumpy, misshapen, but revolutionary. You hover above his drawing, looking down at the uneven oval. It's almost charming in its imperfection, like a child's first attempt at sketching the family dog. You know it's not quite accurate, but you admire the courage to try to. Herschel wasn't just observing stars. He was daring to imagine the whole structure that they belonged to. That leap from counting pinpoints to conceiving a galactic shape was enormous, and Herschel didn't stop with mapping. He was also the first to notice that stars seemed to drift in a preferred direction, hinting that the sun itself was moving through space. Until then, most people assumed the stars were fixed, a stationary backdrop. Herschel's data whispered otherwise. Even our star had a trajectory, pulling us all along in a great cosmic dance. The galaxy wasn't just a static disk, it was dynamic, alive, flowing. That realization alone was enough to make you dizzy as you hover in his era. Let's slip in a quirky footnote. Herschel, despite his dedication to mapping stars, also composed music. He was an accomplished musician before he turned his attention to astronomy. Imagine finishing a night of star counts and then sitting down at the organ to play. It's almost poetic, charting the symphony of the heavens by night, writing earthly symphonies by day. You wonder if he heard the galaxy as music, each star another note in a sprawling score. Back at his telescope, Herschel peers through the eyepiece again, pencil poised. His counts continue, relentless. And you feel the weight of the task, how absurd it must have been, trying to reduce infinity into little tick marks on paper. Yet there's beauty in that absurdity. Herschel didn't expect to finish the job in his lifetime, but he started it anyway. That kind of stubborn hope is as luminous as any star. You drift above his backyard, the giant telescopes towering like wooden skeletons against the night. Herschel works tirelessly, Caroline records faithfully, and together they begin to sketch a galaxy. It's rough, it's flawed, but it's the beginning of the modern vision of the Milky Way. Not spilled milk, not heavenly frost, but a structured, star-filled system that stretches far beyond imagination. You watch him squint, count, and sketch, and you can't help but smile. Humanity's first galactic cartographer is on the job, and the universe has never seemed bigger. The stars keep whirling around you, and now the scene shifts to the early 20th century, where a tall, quiet man named Shapley is puzzling over the Milky Way's true shape. Unlike Herschel, Shapley wasn't content to just sweep the heavens and count. He wanted hard numbers, distances, a way to figure out not only the galaxy's form, but also where exactly the sun sits within it. His tool of choice wasn't a giant telescope in the backyard, but clusters of stars, globular clusters to be precise. These dense spherical swarms of stars hang around the galaxy like glittery satellites, ancient relics from its earliest days. Shapley's idea was clever. If you could map the distribution of globular clusters, you could infer where the galaxy's centre lies. Think of it like tossing popcorn across a field. The densest pile tells you where the bag burst open. Shapley studied the positions of dozens of these clusters and realised something shocking. They weren't centred on the Sun. Instead, they seemed to orbit a point tens of thousands of light years away, somewhere in the direction of Sagittarius. That point, Shapley argued, was the true centre of the Milky Way. This was a cosmic reality check. Up to then, most astronomers believed the Sun was smack in the middle of the galaxy, the privileged throne of creation. Shapley's work shoved us unceremoniously off that throne. The Sun, he showed, is actually way out in the suburbs, about 25,000 light-years from the galactic centre. It's like finding out you don't live downtown in the glamorous heart of the city. You're in the quiet outskirts, closer to the cow pastures. Historians still argue whether Shapley grasped how much this demotion would sting human pride, but it's hard to overstate how revolutionary it was. You hover above Shapley as he works with plates of photographic images, measuring positions and brightnesses. It's tedious work, but he knows these clusters are ancient, luminous breadcrumbs leading him to the galaxy's heart. Fun tidbit: some of these globular clusters are older than the Milky Way's spiral arms themselves, holding stars over 12 billion years old. They're like grandparents keeping family secrets, orbiting quietly in the galactic halo. But Shapley's genius wasn't without flaws. To estimate distances, he relied heavily on Cepheid variable stars that pulse in brightness with predictable rhythms. Henrietta Leavitt had discovered the relationship between a Cepheids period and its true luminosity, essentially giving astronomers a galactic yardstick. Shapley used this tool, but his calibration was off, making his galaxy estimates about twice as big as reality. According to him, the Milky Way was roughly 300,000 light-years across, gargantuan compared to today's accepted 100,000 to 200,000. Still, even with the error, the core idea stuck. The Sun is not the centre, and the galaxy is vastly larger than Herschel ever imagined. You drift through a globular cluster in your mind's eye, stars packed so tightly you could have a dozen suns filling the sky brighter than the moon. It's dazzling, almost claustrophobic, a reminder of just how different stellar neighbourhoods can be. If Earth orbited a star in such a cluster, night would never really be dark, every direction would blaze with starlight. That makes our quiet corner of the galaxy feel positively sleepy, like living in a rural village instead of Times Square. Here's a quirky fact. Some astronomers in Shapley's era actually resisted the idea that globular clusters orbited the Milky Way's centre. A few even thought they might be separate, smaller galaxies, like miniature Milky Ways. The terminology back then was confusing. Nobody had a firm definition of what a galaxy was yet. The word itself comes from the Greek for Milky Circle, but whether there was one big galaxy or many island universes was still hotly debated. Shapley was staking his claim firmly. The Milky Way was the whole show, and everything else was local decoration. Spoiler alert, he'd be proven only half right. You linger on the image of Shapley's map, a lopsided oval dotted with clusters stretched towards Sagittarius. For the first time, the galactic centre is shifted away from the Sun. It's a humbling sketch, one that forces humanity to see itself not as cosmic royalty, but as a quiet tenant on the edge of town. It's worth pausing to appreciate how hard that must have been to swallow in the 1910s, when most people were still clinging to geocentrism's comforting aftertaste. And yet, even with his overestimates and shaky calibrations, Shapley's insight paved the way for everything that came next. By showing that the Sun wasn't central, he set the stage for the Great Debate, the showdown that would decide whether the Milky Way was the entire universe or just one galaxy among many. You can almost hear the murmurs building, like the thunder on the horizon, as astronomers prepared to argue the biggest size question of all. For now, though, you're floating among Shapley's clusters, each one glittering like a disco ball in the dark. They're ancient, wise, patient, and together they whisper the truth. The Milky Way is larger than you think, and you're not the star of the show. You smile faintly at the humility of it, letting the clusters drift past like glowing jellyfish in the ocean of night. The stars shift again around you, and now you're seated in a crowded auditorium in Washington, D.C. in the spring of 1920. It smells faintly of dust and chalk, and the air hums with anticipation. On stage, two astronomers prepare to argue about nothing less than the size of the universe. Harlow Shapley, tall and serious, stands at one podium. At the other is Heber Curtis, sharp-eyed and just a touch fiery. This isn't a boxing match, but it's close. The audience knows they're about to witness the great debate. The question sounds almost simple. Is the Milky Way the entire universe? Or is it just one of many galaxies? Shapley, fresh from his work on globular clusters, believes the Milky Way is absolutely massive, hundreds of thousands of light years across, and everything we see in the night sky, even those mysterious spiral nebulae, belongs to it. Curtis, on the other hand, insists those spirals are separate island universes, galaxies in their own right, floating far beyond the Milky Way's borders. One galaxy or billions? One home or a neighbourhood? Humanity is about to choose sides. You lean in as Curtis makes his case. He points to the appearance of novae, exploding stars seen inside spiral nebulae. If these nebulae were part of the Milky Way, the novae would appear blindingly bright, brighter than anything else in the galaxy, but they don't. That suggests the spirals are much farther away, too distant to belong to our Milky Way. Curtis argues that the Milky Way is large, but not absurdly so, and that those spirals, Andromeda among them, are separate galaxies entirely. He's basically telling the crowd, "Folks, the universe is way bigger than you think." Shapley responds with equal conviction. He counters that the Sun is not at the centre of the Milky Way, and that his globular cluster studies show the galaxy as enormous, far bigger than Curtis allows. He doesn't deny the spirals exist, but claims they're part of our galactic empire, not separate kingdoms. You watch him adjust his glasses, voice steady, insisting that the Milky Way is the universe, or at least the main stage of it. Historians still argue whether Shapley truly believed that all of creation was confined to our galaxy, or if he was hedging his bets. Either way, his confidence is palpable. The audience listens, scribbles notes, and occasionally whispers. Imagine being there. No Hubble Space Telescope yet, no high-definition images of galaxies, just fuzzy patches of light and educated guesses. The stakes couldn't be higher. Either the universe ends at the Milky Way's edge, or it stretches into an endless sea of galaxies. It's like debating whether your hometown is the whole planet, or just one city in a vast world. A quirky side note. This debate wasn't actually a fiery shouting match. Despite the grand title, Great Debate, the event itself was fairly polite, almost subdued. No tables flipped. No mic drops. Both men laid out their arguments carefully, almost academically, though their underlying rivalry was sharp. In fact, later summaries of the event sounded more dramatic than the evening itself. If you were hoping for astronomy's version of a WWE showdown, you'd be a little disappointed. Still, the intellectual stakes made it historic. At the time, neither side had conclusive proof. Curtis's argument about novae was strong, but distances remained fuzzy. Shapley's cluster work was groundbreaking, but his distance scales were inflate. The debate ended without a clear winner, leaving the field wide open. You imagine the audience shuffling out afterward, murmuring to each other, "So, is the universe huge, or just kind of big?" Nobody knew for sure. Here's the delightful twist. Both men were partly right and partly wrong. Shapley was correct that the Milky Way is much larger than Herschel thought, and that the Sun is not at its centre. Curtis was right that the spiral nebulae are separate galaxies, not local clouds of gas. The real answer, our modern one, was a hybrid. The Milky Way is huge, yes, but it's also just one of billions. You hover in the auditorium as the crowd fades, realizing you're watching a pivot point in human understanding. For millennia, people thought Earth was the center. Then Copernicus and Galileo moved us around the sun. Shapley shoved us into the galactic suburbs. And now Curtis was daring to say the Milky Way itself isn't special. It's just one island in an ocean too vast to fathom. That idea would take years, and Edwin Hubble's work with Cepheids to settle. But the seeds were planted here in this quiet debate. It's humbling to imagine how it felt. You'd spent centuries shrinking the universe into manageable proportions, only to discover, step by step, that it's always bigger than you thought. Andromeda isn't a cloud in your backyard, it's a full-fledged galaxy 2 million light-years away, heading toward us like a slow-motion train. The Milky Way isn't the universe, it's just your city block. Every answer only pushes the horizon farther. As you float away from the debate hall, you carry that realization with you. Even polite arguments can remake the cosmos. The Milky Way is grand, but it's not all there is. The universe is vaster, stranger, and more crowded than even Shapley or Curtis dared to fully believe. You drift forward again, and now you're perched beside a quiet desk in the early 20th century, where Henrietta Swan Leavitt is poring over stacks of photographic plates. The room is dim, lit only by the soft glow of lamps, and the plates shimmer faintly with the tiny black pinpricks of stars. Leavitt was one of the so-called computers at the Harvard College Observatory, women hired to do the painstaking data work that male astronomers often considered beneath them. But what she uncovered in that tedium changed astronomy forever. Leavitt was studying Cepheid variable stars, those strange suns that rhythmically brighten and dim like celestial lighthouses pulsing across the dark. She noticed something subtle. The longer a Cepheid's period of pulsation, the brighter it actually was. In other words, if you measure how quickly a Cepheid flashes, you can calculate its true luminosity. Compare that intrinsic brightness with how faint it looks from Earth, and voila, you've got its distance. This was the breakthrough astronomers had been begging the universe for, a yardstick that stretched far beyond parallax or guesswork. Historians still argue whether Leavitt fully realized the galactic and intergalactic implications of her discovery. What's certain is that she handed the world a cosmic measuring tape, one that Shapley used to gauge globular clusters and one Edwin Hubble would later wield to prove the existence of galaxies beyond the Milky Way. Without her, the great debate might have dragged on for decades longer. And yet, in her own lifetime, Leavitt never received the recognition she deserved. Male colleagues used her data, built reputations on her insight, while her name lingered quietly in the footnotes. You hover beside her as she squints at another plate, ruler in hand, ticking off the tiny specks. Imagine the patience, hours, days, years of staring at flickering stars, measuring their cycles by eye. There's nothing glamorous about it, just meticulous observation, and yet that quiet diligence cracked open the door to the universe's true scale. A quirky little tidbit. Leavitt's discovery was so significant that some later astronomers proposed naming the unit of distance a Leavitt, though it never quite caught on. Still, the idea lingers as a reminder of her role as the architect of cosmic yardsticks. With Cepheids, suddenly astronomers weren't just making rough guesses, they could measure the Milky Way's size with more confidence, and soon they could leap beyond it. The Milky Way no longer had to be drawn as Herschel's grindstone or Shapley's bloated oval. It could be measured, calibrated, quantified with a precision that must have felt almost magical. You imagine astronomers of the 1910s and 1920s holding their breath as they realized these pulsing stars were not just pretty curiosities, but universal rulers. Of course, Cepheids weren't perfect. At first, astronomers didn't know there were two different types, classical Cepheids and type 2 Cepheids, with slightly different brightness rules. Mixing them up could throw off distance estimates by the large factors. Shapley himself made this mistake, inflating the size of the Milky Way by using the wrong calibration. Still, even with errors, the method worked better than anything humanity had before. It was like moving from guessing how tall someone is by squinting to actually using a tape measure, even if the tape was a little warped. You imagine yourself watching one of these Cepheid stars in real time. It swells, its outer layers expanding like a balloon, and the light grows stronger. Then gravity tugs it back inward, the brightness dips, and the cycle repeats. From Earth, it looks like a soft heartbeat in the sky, steady and dependable. These stars are scattered across the Milky Way's arms, little lanterns waiting to be timed and measured. To ancient stargazers, they were just flickering points. To Leavitt, they became the key to unlocking galactic distances. A quirky footnote for your dreamy stargazing tonight. Leavitt herself had hearing loss and spent much of her life in relative quiet. Perhaps that silence sharpened her patience for the flickering rhythms of stars. It's almost poetic, she may not have heard music easily, but she discovered the universe's deepest tempo, the pulsations of Cepheids beating across space. As you float back from her desk, you feel the scale of the achievement. Counting stars by eye, Herschel gave us a map. Shapley's clusters showed us we're off-centre. But Leavitt gave us the ruler, the tool that let us measure not only the Milky Way but also Andromeda and beyond. It's humbling to realise how much of modern cosmology rests on the quiet, painstaking labour of a woman whose name most people still don't know. You glance upward, past the walls of the observatory, and the Milky Way glows again above you. The stars don't look any closer, but now you know they can be measured. Their distance is charted with a flicker and a calculation. The galaxy isn't just a blur anymore, it's a structure with numbers attached. And once you start measuring, there's no going back. The Milky Way is big, yes, but soon you'll discover it's just the first step in an even bigger cosmic staircase. You drift forward in time again, the stars flickering like lanterns on a rolling tide, until you find yourself surrounded not by telescopes of glass, but by the hum of radio dishes. It's the mid-20th century now, and astronomers have started listening to the galaxy instead of only looking at it. Light is wonderful, but dust clouds block much of the Milky Way's starlight, leaving huge swathes invisible. Radio waves, though? They slide right through the dust, carrying secrets straight to our receivers. Suddenly, the galaxy has a new voice. The breakthrough came when astronomers realized they could map neutral hydrogen, the most abundant element in space, by detecting its signature 21-centimeter emission line. Every hydrogen atom has this little quirk. When its electron flips orientation, it releases a photon of radio light at exactly that wavelength. It's a cosmic beacon, and by tuning antennas to that frequency, scientists could trace hydrogen gas across the Milky Way. You imagine the first time those signals scrolled across a chart recorder, the jagged lines revealing spiral arms hidden behind dark curtains of dust. For the first time, the Milky Way's structure started to come into focus, not just as a blurry disk, but as a system with distinct arms wrapping around a central bar. What Herschel guessed at with his eye, and what Shapley approximated with clusters, radio astronomy confirmed in stunning detail. The Orion arm, the Sagittarius arm, the Perseus arm, whole lanes of stars and gas coiling outward like grooves on a record. Historians still argue whether the galaxy has 2 or 4 major arms, because radio maps don't always agree perfectly, but the picture was revolutionary. A quirky tidbit: some of the earliest radio astronomy in the 1930s and 40s was done with equipment that looked more like repurposed radar than sleek scientific gear. Carl Jansky, often called the father of radio astronomy, actually stumbled on cosmic static while working for Bell Telephone Labs in the 1930s. He built a giant rotating antenna, nicknamed Jansky's merry-go-round, to track sources of interference. When he realized the hiss repeated every sidereal day, he traced it back to the center of the Milky Way. Imagine thinking you're just troubleshooting phone calls, only to discover the galaxy is talking to you. By the 1950s, teams in the Netherlands, Australia, and the US were building proper radio telescopes and sweeping the sky systematically. As the data piled up, maps of hydrogen gas began to show not only the arms, but also their motion. Gas clouds orbit the galaxy in graceful arcs, their Doppler shifts betraying how fast they move. That's when the surprises started. The Milky Way's outer regions weren't slowing down as expected. Instead, the rotation curves stayed flat, hinting at unseen mass, dark matter, lurking far beyond the visible disk. The galaxy wasn't just big, it was heavier, bulkier, stranger than anyone had guessed. You hover above a mid-century observatory, a giant parabolic dish gleaming under the stars. Its motors whir softly as it tilts skyward, chasing invisible waves. Inside the control room, paper charts crawl with squiggling lines, each bump a gas cloud, each dip a clue. To modern eyes, it looks quaint, even primitive. But to those astronomers, it was like putting on glasses after years of blurred vision. For the first time, the Milky Way's skeleton was visible, drawn in hydrogen. Historians still debate how much credit belongs to which teams, since several groups raced to map the galaxy at once, but the collective outcome was clear. We live in a barred spiral galaxy, one with arms stretching outward and a bar slicing through the center. Suddenly, those hazy myths of spilled milk were replaced with crisp structural diagrams. The Milky Way wasn't just pretty, it was an engine, pumping stars and gas along vast lanes. Here's a fringe detail that makes you smile. Early radio astronomers sometimes had to battle interference from things like car ignitions or even kitchen appliances. Imagine trying to map the galaxy's spiral arms while your neighbour's toaster keeps showing up as static. Yet they persevered, filtering the noise until the cosmic signal stood out. There's something wonderfully human about that, untangling the Milky Way's voice from the background hum of earthly breakfast. As you drift among those hydrogen clouds, you can almost hear them singing. Each one glows faintly at that precise 21-centimetre line, a chorus of whispers stretching across thousands of light years. You follow the trails, watching them coil into spirals, tracing paths you couldn't see with your eyes alone. The galaxy feels alive now. Like a giant whirlpool, each cloud swept along in its orbit. And here's the big takeaway. Radio astronomy didn't just confirm the Milky Way's arms, it extended our sense of scale. The galaxy wasn't a fuzzy band anymore. It was a sprawling structure at least 100,000 light-years wide, possibly more. Even better, radio maps hinted at arms continuing farther out, ghostly and faint. The edges were no longer crisp. They blurred into distant gas, suggesting the Milky Way's reach is bigger than any single definition allows. You float back from the dish, the stars returning to silence, but you know you've just listened to the galaxy's true language. Through radio waves, the Milky Way revealed its shape, its arms, and its restless spinning heart, and for the first time you feel less like a spectator under spilled milk and more like a passenger in a vast rotating machine. You linger in that hum of radio waves a little longer, but soon another layer of mystery settles over you, the invisible weight of the galaxy itself. By the mid-20th century, astronomers had a pretty good sense of the Milky Way's spiral arms and approximate size, yet something wasn't adding up. The stars, the gas, the glowing nebulae, all the visible matter combined, simply weren't enough to account for the way the galaxy moved. The math was off. It was as if the Milky Way was playing a game of hide-and-seek with its own mass. The problem became obvious when astronomers plotted the galaxy's rotation curve, a graph of how fast stars orbit the centre at different distances. If the Milky Way were made only of visible matter, stars far from the centre should orbit more slowly, just as planets farther from the Sun crawl around at a leisurely pace. But that's not what the data showed. The outer stars were whipping around just as fast as the inner ones. Like a carousel whose horses all gallop at the same speed no matter how far they sit from the axis, something unseen had to be keeping them from flying off into the void. Enter the idea of dark matter. Astronomers proposed that the Milky Way, like other galaxies, was embedded in a massive halo of invisible material. It doesn't glow, it doesn't absorb light, but it tugs with gravity. Historians still argue about the origins of the concept, whether Fritz Zwicky's 1930s observations of galaxy clusters really count as the first clear case. But by the 1970s, thanks to Vera Rubin's meticulous work on spiral galaxies, the evidence was overwhelming. The Milky Way wasn't just made of stars and gas. Most of its mass was this ghostly stuff we couldn't see. You imagine yourself drifting along one of those outer orbits, watching stars zip by at speeds they shouldn't be able to sustain. The invisible halo presses in around you, not oppressive but steady, like an unseen scaffolding holding the galaxy together. Without it, the Milky Way would unravel. With it, the galaxy's true size swells far beyond its glowing disk. Instead of 100,000 light-years across, the Milky Way's dark matter halo might extend 1 million light-years or more. Suddenly, your galactic neighbourhood looks less like a pinwheel and more like a glowing core floating inside an invisible balloon. Here's a quirky tidbit. Dark matter doesn't just add weight, it complicates galactic cartography. When astronomers talk about the size of the Milky Way, they often mean the visible disk. But if you include the dark matter halo, the numbers balloon. Some press releases claim the Milky Way is 1 million light-years wide, others stick to the more modest 100,000. Both are correct, depending on whether you count the hidden scaffolding. It's a bit like deciding whether your city ends at the downtown lights or includes all the suburbs and farmland around it, and yet dark matter remains stubbornly mysterious. Despite decades of searching, we still don't know what it is. Some think it's made of exotic particles like WIMPs, weakly interacting massive particles. Others suggest axions, still others toy with the idea that maybe gravity itself behaves differently on large scales. Historians still argue whether our inability to detect dark matter directly is the failure of technology or of imagination. You drift through this debate like a leaf on the wind, surrounded by invisible matter that might not even exist the way we picture it. What's certain, though, is that the Milky Way is much heavier than its stars alone suggest. Current estimates put its mass at about 1 trillion times that of the Sun. Most of that, up to 85%, is dark matter. In other words, the galaxy you see, the one that dazzles with stars and nebula, is just the tip of the iceberg. The real bulk is hidden, a shadow galaxy overlapping the luminous one. It's a strange thought. When you look up at the Milky Way on a dark night, you're only seeing a fraction of what's actually there. The rest is invisible scaffolding, silently shaping everything, a fringe tidbit worth savouring. Some astronomers have speculated that small dark matter, clumps, subhalos, drift through the Milky Way like ghosts. If one of them passed through our region, it might tug subtly on comets or stars, leaving faint fingerprints. There's no evidence of such an encounter yet, but the thought that invisible blobs might be cruising past us at this very moment is, well, let's just call it a little spooky. You let that idea sink in. The Milky Way isn't just bigger than Herschel guessed, or larger than Shapley measured. It's bigger still, swollen by unseen matter that doubles, triples, or even quadruples its true size. The disk, the arms, the clusters, those are just the visible ornaments. The real Milky Way is a heavyweight champ wrapped in an invisible cloak. You float there for a moment, letting the enormity of it settle over you, like a weighted blanket woven from mysteries. The stars around you thin out, stretching into faint and lonely specks, until the Milky Way's brilliant spiral arms seem to fade behind a veil. You've drifted beyond the glowing disk into a region that feels ghostly, hushed, and ancient, the stellar halo. If the galaxy's disk is the bustling city, its halo's the quiet countryside, vast and sparsely populated, with relics from an earlier age scattered across the dark. It's easy to forget this part exists, because you can't see it with your naked eye. But astronomers now know the halo's enormous, extending hundreds of thousands of light years in every direction, far beyond the bright whirl of the arms. What makes the halo special isn't just its emptiness, but its resonance. The stars here are ancient, some of the oldest in the Milky Way, born more than 12 billion years ago. They're low in metals, that's astronomer speak for any element heavier than helium, because they formed when the universe itself was young and hadn't yet cooked up much in the way of heavier stuff. You can imagine these stars as the galaxy's elders, glowing faintly and patiently while generations of younger stars in the disk come and go. Historians still argue whether all of these halo stars were born within the Milky Way, or if many were captured from smaller galaxies long ago. Either way, their presence tells the story of the galaxy's rough childhood. You drift through a globular porous cluster hanging in the halo. One of those dense star swarms Shapley used to trace the Milky Way's centre. Inside, stars are packed so tightly you could mistake the sky for a jewelled dome. These clusters orbit far above and below the galactic plane, like loyal satellites circling an unseen throne. A quirky tidbit: the Milky Way is home to around 50 known globular clusters, but astronomers suspect more are still hidden in the halo, faint and overlooked. They are like old family albums, each cluster preserving snapshots of stellar evolution billions of years ago. But the halo isn't just made of stars, it's also filled with dark matter, likely making up most of its mass. That invisible halo overlaps the stellar one, creating a layered ghost-on-ghost structure. And beyond even that lies the hot gas corona, a faint, diffuse bubble that may stretch as far as halfway to Andromeda. When you stack all these layers together, the Milky Way's halo is so vast it dwarfs the bright disk by orders of magnitude. The galaxy you picture when you see that band of light at night, that's just the glowing heart of a far larger, ghostly beast. Here's a quirky fringe detail. Some stars in the halo are hypervelocity stars, moving so fast they're practically being flung out of the galaxy. Many of these speedsters were likely accelerated by close encounters with the supermassive black hole at the centre. Others may be the shredded remains of smaller galaxies that strayed too close. Either way, they're racing through the halo like sparks blown from a campfire, destined to escape entirely and drift forever in intergalactic space. If you could hitch a ride on one, you'd have a one-way ticket out of the Milky Way, no return trip possible. As you float farther into this faint region, the sense of scale becomes overwhelming. In the halo, distances between stars stretch wider and wider, until loneliness itself feels like part of the landscape. The spiral arms are a distant memory, and the familiar constellations of Earth's sky dissolve into new, alien patterns. You realise how parochial the night sky is. Our constellations only make sense from inside the disk. Out here in the halo, Orion doesn't even look like Orion anymore. Yet despite its sparseness, the halo is crucial for understanding the Milky Way's size. Measuring its extent is like trying to determine where your city ends when suburbs and farmland taper off into wilderness. Some astronomers argue the stellar halo stretches 300,000 light-years. Others suggest its faintest members may drift much farther. Historians still debate the exact cutoff. Do you count the last faint star, the farthest globular cluster, the edge of the dark matter halo? Or is the halo truly endless, fading into the intergalactic medium with no hard boundary? You glance back toward the glowing disk, now just a faint smear of light, and feel a strange pang. From Earth, the Milky Way looks crowded, teeming with stars. Out here, it looks fragile, a wafer-thin structure floating in a balloon of near nothingness. The halo teaches you humility. The galaxy is both vast and delicate, built from ancient bones and invisible scaffolding. Its edge isn't sharp, it frays into the void like a fabric unravelling. And maybe that's the most astonishing part. The Milky Way's true size isn't defined by the brilliant lights you see at night. It's defined by this faint halo, sprawling quietly in all directions, reminding you that the galaxy is larger, older, and stranger than your imagination usually allows. You breathe slowly, letting the emptiness settle around you, and accept that you're just a tiny speck in a galactic halo that stretches almost beyond comprehension. You hover in the dim outskirts of the halo, but soon you notice something else drifting through the Milky Way's invisible borders, streams of stars, faint and elongated, like rivers unravelling in the night. They don't look like natural spiral arms. They're too narrow, too stretched, trailing across tens of thousands of light-years. These are the ghostly remains of smaller galaxies the Milky Way has devoured, their stars ripped from their homes and left as tidal debris. The galaxy isn't just a peaceful pinwheel, it's a cosmic predator, and you're floating among the evidence of its long appetite. The most famous of these is the Sagittarius Stream, a sprawling ribbon of stars wrapped nearly all the way around the Milky Way. It's the shredded remains of the Sagittarius dwarf galaxy, which wandered too close and was torn apart by gravity. Astronomers can trace its arc across the sky, looping like a giant belt. Imagine a moth drawn too close to a flame, wings fraying as it circles. The Sagittarius dwarf is that moth, its stars scattered into the Milky Way's halo. Historians still argue about how many times this dwarf galaxy has orbited and been stripped, but its slow death shows just how ruthless the Milky Way can be. And Sagittarius isn't alone. There are other streams, the Orphan Stream, the GD1 Stream, the Palomar 5 Stream, each one the whisper of a lost system. Palomar 5 is especially quirky. Once a globular cluster, its stars are so stretched out that astronomers sometimes joke it's more a pair of tails than a cluster. It's basically a comet made of stars doomed to dissolve completely. You drift along one of these streams, feeling the eerie beauty of it. Stars aligned like pearls on a broken necklace, trailing endlessly into the dark. The discovery of these streams was a slow process. Early photographic plates hinted at odd over-densities of stars, but it wasn't until large sky surveys like the Sloan Digital Sky Survey in the 2000s that the full extent of the streams became obvious. Computer algorithms picked out the subtle alignments, and suddenly the halo looked like a spiderweb of stellar rivers. The Milky Way wasn't a serene structure. It was scarred, constantly reshaped by the meals it had eaten. It's a reminder that galaxies grow not just by forming stars, but by cannibalizing their smaller neighbors. Here's a quirky tidbit. Our galaxy is currently in the process of tearing apart the Magellanic Clouds, two irregular dwarf galaxies that are visible to the naked eye from the southern hemisphere. A massive ribbon of gas, the Magellanic Stream, trails behind them, a kind of cosmic breadcrumb trail. It hasn't fully turned into a stellar stream yet, but give it a few billion years and it will. The Milky Way is patient. It doesn't snack quickly. It dines slowly, savouring each course over cosmic timescales. You hover near one of these streams and imagine what it would be like to live on a planet orbiting a star within it. Your night sky would be unlike anything seen from Earth. Instead of faint constellations, you'd see a glittering arc of sibling stars stretching across the heavens, a permanent reminder of your galaxy's violent past. Historians still debate whether some of the halo's oldest stars began their lives in the Milky Way, or were captured from these unfortunate dwarfs. Either way, the halo's makeup is patchwork, stitched together from countless galactic mergers. And this process isn't over. In about 4 billion years, the Milky Way itself will merge with Andromeda, and the two galaxies will shred each other's stars into even grander streams. What you see now in the halo, the faint tidal rivers, is just the appetizer. The main course is still ahead. It's funny, in a slightly unsettling way, that your galaxy is both home and predator, builder and destroyer. It grows by stealing, reshaping itself with every meal. You let your gaze wander across the halo and see not emptiness but motion. Streams, crisscrossing, arcs looping, stars gliding silently on disrupted orbits. The Milky Way isn't static, it's still assembling itself from the bones of smaller galaxies. Each stream is a scar, a history lesson written in stars instead of ink. And maybe that's the real revelation. The galaxy's size isn't just about the disk or the halo, it's also about these streams, these faint fingers stretching outward, blurring the edge even farther. The Milky Way doesn't have clean borders, it has tattered edges, constantly redrawn by the galaxies it consumes. You float there among the streams, listening to their silence, and you feel the immensity of a galaxy that is still growing, still hungry, still unfinished. You leave behind the ghostly rivers of stripped stars, only to find yourself gliding into an even stranger envelope around the Milky Way, a vast, invisible shroud of hot gas. Astronomers call it the galactic corona, though it has nothing to do with the sun's delicate crown of light. This is the Milky Way's own atmosphere, a blisteringly hot halo of ionized gas that surrounds the galaxy like an enormous bubble. It's so diffuse that if you scooped a cup of it, you'd barely collect a single atom, yet stretched across hundreds of thousands of light years, it holds more matter than you might guess. The existence of this corona wasn't obvious at first. In the 1960s and 70s, astronomers suspected something was out there, because galaxies seemed to be bleeding gas into space without running dry. Then X-ray observations revealed faint glows around galaxies, including our own. The Milky Way's corona, heated to millions of degrees, shines weakly in X-rays, a ghost light only visible to specialized detectors. You picture an astronomer squinting at a grainy X-ray image, whispering, "Oh, there it is, our galaxy's cloak." This corona isn't just decoration. It may double the Milky Way's effective size. While the visible disk stretches about 100,000 to 200,000 light-years across, the corona may extend 300,000, 500,000, maybe even 1,000,000 light-years. That's large enough to overlap with Andromeda's corona. In fact, some astronomers suspect the two bubbles are already touching, like soap suds colliding. Historians still argue whether this overlap means the galaxies are already interacting in some sense, long before their spheres begin to merge in 4 billion years. A quirky tidbit. The corona contains more than just hot gas. Embedded in it are stray stars, wandering globular clusters, and even entire dwarf galaxies slowly spiraling inward. The corona acts like a cosmic sponge, catching whatever drifts too close. It may also be recycling matter from supernovae. When stars explode in the Milky Way's disk, they blast material outward, which then cools and trickles back down like galactic silt rain. You could call it the Milky Way's weather system, the one running on scale so vast that a single raindrop might take millions of years to fall. You float in this haze, and it doesn't feel empty. The gas is invisible to your eyes, but real enough to tug, to heat, to scatter X-rays. You imagine what Earth's night sky would look like if you could see the corona in visible light. Instead of a crisp, starry black, the heavens would glow faintly with diffuse fire, a reminder that you live deep inside a hot cocoon. It would be beautiful in a strange, unsettling way, like discovering your house has been floating in a giant bubble all along. And here's where the size question gets really slippery. If you count the disk, the Milky Way is 100,000 to 200,000 light-years wide. Include the stellar halo, and it balloons to 300,000. Add the dark matter halo, and it stretches 1,000,000. Factor in the corona, and suddenly you realize the concept of the Milky Way's edge is fuzzy at best. Historians still argue whether we should teach schoolkids the disk size, the halo size, or the corona size. The answer, of course, depends on what you mean by galaxy. A fringe note worth savouring: astronomers studying quasar light have found that the Milky Way's corona is laced with heavy elements like oxygen, silicon, and carbon, the fingerprints of past generations of stars. That means the corona isn't just leftover primordial gas. It's enriched, processed, recycled. Every breath you take on Earth contains atoms that were once inside stars. The corona is the same, only on galactic scales. You're floating in a reservoir of stellar afterlives, the ashes of billions of suns stretched thin across space. You let the corona wrap around you. its hot winds invisible but immense. It's not the kind of structure you can point to with your eyes. It's not a pretty spiral arm or a glowing nebula. It's subtler, quieter, a faint cocoon of gas that holds the Milky Way together and blurs its edge into the void. And in the vast hot silence, you feel the size of the galaxy expand yet again, larger than the myths, larger than Herschel's maps, larger than even Shapley's inflated estimates. The corona humbles you with its scale, but it also soothes you. Its diffuse glow feels like a blanket spread wide across the cosmos, tucking the galaxy in for the long night. You picture yourself drifting off inside it, a tiny mote wrapped in the Milky Way's breath. The stars sharpen into focus again, and now you're peering through the most precise set of eyes humanity has ever pointed at the heavens. The Gaia spacecraft, launched by the European Space Agency in 2013, quietly spins around the Sun at a point of gravitational balance, mapping the positions and motions of stars with exquisite detail. If Herschel was sketching by candlelight and Shapley was measuring by ruler, Gaia is surveying the galaxy with a laser level and a GPS unit, accurate down to the tiniest decimal. Gaia's mission is deceptively simple. Measure where stars are and how they move, but the scale of it is staggering. So far, Edgar Ray has charted over 1.8 billion stars, an atlas of the Milky Way like nothing before. Each star's position, brightness, motion, and parallax distance are recorded with such precision that astronomers can trace their orbits backward and forward in time. You picture Gaia as a cosmic librarian, cataloguing stars one by one, and the shelves stretch farther than your imagination can reach. With this data, the shape of the Milky Way has come into sharper relief. We now see the Sun's neighbourhood as part of the Orion Spur, a minor arm wedged between the Sagittarius and Perseus arms. Gaia has revealed ripples in the galactic disk, waves of stars bobbing up and down, perhaps caused by past collisions with smaller galaxies. Historians still argue whether these ripples are the direct fingerprints of the Sagittarius dwarf galaxy's repeated plunges, or if they're echoes of even older mergers. Either way, the galaxy's disk isn't flat and serene, it's rumpled, like a cosmic bedsheet. One quirky tidbit: Gaia's accuracy is so fine that it can detect the wobble of stars caused by unseen planets tugging at them. That means the same dataset mapping the Milky Way's structure is also uncovering thousands of exoplanets. Imagine that. While astronomers use Gaia to redraw the galaxy's edges, others are mining its tables for potential alien homes. It's like buying a microscope to study ants, and discovering it also reveals the fingerprints on your glass. The precision of Gaia's map has redefined the Milky Way's size too. By tracing stars in the outer disk and halo, astronomers can push the galaxy's boundaries with confidence. Instead of fuzzy guesses, we now know the disk spans at least 120,000 light-years, with faint stars stretching farther still. And Gaia's motion data reveals streams of stars, confirming the galaxy's cannibalistic history. You drift among them, watching the orbits intertwine, seeing the Milky Way not as a static photo, but as a living, breathing, shifting organism. Gaia also confirmed something humbling. The Milky Way isn't a tidy four-armed spiral like you see on textbook covers. Instead, it's lopsided, with arms that are patchy and asymmetrical, some cut short, others extended. The bar at its centre twists the orbits into warped paths. The neat, perfect spirals of artists' illustrations are more fantasy than fact. The real Milky Way is messy, irregular, and alive. And somehow that makes it more beautiful. You drift closer to Gaia itself, a golden hexagon of solar panels glinting against the void. It quietly spins, instruments locked on its stellar targets, gathering data in silence. Down on Earth, supercomputers crunch those measurements, transforming numbers into maps so vast they barely fit on a human brain's mental canvas. Every update from Gaia is like another page in the atlas, filling in blank spaces where once there were only guesses. Historians still argue whether Gaia's final dataset will settle the Milky Way's size once and for all, or simply raise new questions. After all, with every new layer of precision, the galaxy seems to grow more complicated, a fringe detail to savour. Gaia has even measured tiny stellar earthquakes, subtle flickers in brightness caused by oscillations inside stars. That means this one mission isn't just mapping where stars are, but listening to their vibrations, reading their interiors like seismologists probing Earth's crust. You realise the galaxy isn't just being mapped, it's being felt, probed down to the quivers of its suns. You let your gaze wander back across Gaia's growing map, and it feels like standing on a cliff overlooking a vast, intricate city at night. Streets of stars twist into spirals, neighbourhoods stretch outward, suburbs fade into countryside. The Milky Way has never felt so detailed, so immense, so vibrantly alive. You're not staring at a smear of light anymore. You're holding a galactic census, a star-by-star record of your cosmic home. And thanks to Gaia, the edges are no longer quite so fuzzy. They're sharp enough to whisper, yes, this is how big the Milky Way really is. The Milky Way spins around you, its spiral arms glowing faintly in the dark, and now your gaze drifts outward, toward a neighbour. Across the void, about 2.5 million light-years away, the Andromeda Galaxy hangs like a luminous swirl, larger and brighter than our own when seen through a telescope. You can almost feel the tension between the two. The Milky Way and Andromeda are the twin giants of the local group, circling each other in slow motion, destined to collide. Comparing them is irresistible, like sizing up rival cities. Who's bigger? Who's heavier? Who wins the cosmic arm wrestle? For a long time, astronomers assumed Andromeda had the edge. Its disk looked wider, perhaps 20,000 light-years across, compared to the Milky Way's 100,000 and 200,000. Its central bulge seemed more massive, its star count greater, roughly 1 trillion stars compared to our few hundred billion. The narrative was set. Andromeda was the heavyweight, and we were the slightly smaller sibling. Historians still argue whether that perception was partly due to our awkward vantage point inside the Milky Way, unable to see our galaxy as cleanly as we can view Andromeda from the outside. But in recent years, Gaia's data and other surveys have flipped the script. It turns out the Milky Way may be just as massive as Andromeda, possibly even more so, once you include the full extent of our dark matter halo. The visible stars are only part of the equation. The invisible scaffolding matters too. So now, the cosmic rivalry feels like one of those playground debates where two kids insist they're taller, measuring against doorframes with shoes on or off. Quirky tidbit, some estimates even suggest the Milky Way and Andromeda are close enough in heft that it's basically a tie, a galactic sibling rivalry with no clear winner. You let your imagination run forward in time. About 4 billion years from now, the Milky Way and Andromeda will drift into each other's arms, their halos already brushing today. First, the disks will overlap, stretching into tidal tails of stars. Then the centers will dance, orbiting and merging. The result won't be destruction so much as transformation. A single massive elliptical galaxy nicknamed Milkomeda. It sounds like a dairy product, but the reality will be spectacular. Streams of stars, gas clouds colliding, new bursts of star formation lighting up the merged core. To any inhabitants of the time, the night sky will blaze with unfamiliar constellations, Andromeda swelling larger and brighter until the two galaxies become one. Historians still debate what the collision means for Earth. Will our sun be flung into a new orbit? Will our descendants, if they're still around, watch from some future perch, marvelling at the new night sky? The odds of stars colliding are tiny. Galaxies are mostly empty space, but gravitational shuffling will rearrange the suburbs. Imagine moving from a sleepy cul-de-sac into a bustling downtown overnight. The solar system might find itself in a brand new neighbourhood of stars. Here's a fringe tidbit. While the Milky Way and Andromeda are the main players, they're not alone. The local group contains dozens of dwarf galaxies, like the Triangulum Galaxy and the Magellanic Clouds, each tugging and being tugged by the giants. During the eventual merger, these smaller galaxies may be swept up too, feeding the newly formed Colossus. In a sense, the local group is like a family reunion where everyone eventually piles into the same giant house, whether they want to or not. You drift now between the two galaxies, halfway across the void, and the scale stuns you. Each system is enormous, but the gulf of millions of light-years between them is larger still. You glance back at the Milky Way, then forward at Andromeda, and realize you're caught in a slow-motion embrace, one that's been building for billions of years. The galaxies are bound by gravity, fated to meet. There's no stopping it, no sidestep possible. The Milky Way's true size feels even more significant in this context, not because it defines the galaxy alone, but because it shapes how it collides with its twin. Back on Earth, you remember the countless nights when people mistook Andromeda for just another fuzzy star. To the naked eye, it's little more than a smudge. but that smudge is a behemoth rival to our own. And when you compare them side by side, you realise size isn't everything. Both are enormous, both teem with stars, both carry ancient scars from past mergers. Together, they are the rulers of this little corner of the cosmos. And soon, cosmically soon, they'll be one. For now, though, you're still suspended in the gap between them, a silent witness to the slow approach. The Milky Way feels immense behind you, Andromeda immense ahead. You're a speck floating between giants, knowing the future belongs to both of them together. You slip back toward the Milky Way now, zooming past its spiraled arms until you reach the very heart, a place so crowded with stars that the night would look like perpetual fireworks if you stood there. The galactic center isn't a calm neighborhood. It's a frantic downtown, dense with dust, gas, and a swirl of light. And right at the core, tucked inside that glowing hub, lurks the heavyweight anchor of the galaxy, Sagittarius A, a supermassive black hole. You can't see it directly, but you can watch its influence. Stars whip around an invisible point at ridiculous speeds, pulled by a gravity so intense that nothing, not even light, can escape once it crosses the event horizon. Sagittarius A is about 4 million times the mass of the Sun. To put that in perspective, if our solar system orbited it instead of sitting 20,000 light-years away, we'd be circling in tight little loops with no chance of calm seasons or long-lived planets. Luckily, we're far enough away to avoid being spaghettified. But this black hole isn't just a curiosity, it's central to how astronomers measure the Milky Way's size and mass. By tracking the orbits of stars close to Sagittarius A, researchers can estimate the black hole's heft, and from that refine models of the galaxy's structure. It's like weighing a city by watching how fast traffic circles around about downtown. The most famous of these stars is S2, a young hot star that orbits Sagittarius A once every 16 years. Astronomers have tracked its path with exquisite precision, watching it slingshot dangerously close to the black hole before swinging back out. When S2 nears pericenter, the closest point in its orbit, it moves at over 7,000 kilometers per second. That's about 2.5% the speed of light, fast enough to zip from Earth to the Moon in under a minute. Observing S2's motion provided not only confirmation of the black hole's mass, but also a test of Einstein's general relativity. Sure enough, the light from S2 redshifted just as relativity predicts, bending reality itself around Sagittarius A. Historians still argue whether Sagittarius A has always been this quiet. Today it's relatively tame, occasionally burping X-rays as it snacks on stray gas clouds, but evidence suggests it may have been far more active in the past. Some researchers propose that a few million years ago, it flared so brightly it lit up giant gas clouds thousands of light-years away. The Fermi bubbles, enormous lobes of gamma rays stretching above and below the galactic disk, may be scars of that ancient outburst. Imagine living in the Milky Way during one of those flare-ups, the night sky glowing eerily, Earth bathed in radiation from the galaxy's hungry core. A quirky tidbit: despite its mass, Sagittarius A is small in physical size. Its event horizon would fit comfortably inside Mercury's orbit. That's tiny compared to the sprawl of the Milky Way. It's like a pinhead anchoring a cathedral. Yet without it, the galactic center's stars wouldn't orbit so tightly, and the structure of the bulge might look very different. Supermassive black holes, it seems, are less about gobbling everything in sight and more about shaping the gravitational ballet of galaxies. You float above the galactic center, and it feels chaotic. Stars zipping like fireflies, gas clouds colliding, shockwaves rippling outward. And yet, the presence of Sagittarius A gives it order. It's the silent conductor at the heart of the orchestra, unseen but undeniable. The Milky Way's true size can't be measured without acknowledging the black hole's role. By studying the stars it governs, astronomers refine their distance scale to the galactic center, a key reference point for measuring everything else. Get the center wrong, and the whole map wobbles. Here's a fringe detail to add some spice. Some astronomers wonder if Sagittarius A is part of a binary black hole system. If the Milky Way swallowed a smaller galaxy in the recent past, its black hole might still be orbiting near the core, hidden in the glare. Detecting such a companion would be challenging, but not impossible, and if found, it would reshape how we understand galactic mergers. The idea is speculative, but it's tantalizing to think our galaxy's heart might contain not one monster, but two. As you hover there watching S2 race through its orbit, you can't help but feel awed. The galaxy, for all its arms and halos and streams, revolves around this invisible anchor. Herschel drew maps, Shapley measured clusters, Gaia charts the suburbs, but Sagittarius A is the gravitational truth at the centre. Without it, the Milky Way would be unmoored. You let yourself drift back, away from the crowded hub, carrying the image of the black hole's dark weight. It doesn't glow, it doesn't announce itself, but its pull defines the galaxy's shape. The Milky Way's size is written in the paths of stars that dare to dance near its heart. And you realise the core isn't just a place, it's the keystone holding the whole vast structure together. You drift farther out again, pulling back from the galaxy's crowded heart, and a question begins to nag at you. Where does the Milky Way actually end? It sounds simple, like asking where a city's borders lie, but the galaxy refuses to offer a neat answer. Unlike a town with a welcome sign, the Milky Way's edges are hazy, layered, and contested. Every time astronomers think they've drawn a boundary, some faint stream of stars or stray cloud of gas pushes the line farther out. It's the cosmic equivalent of trying to fence in fog. The problem starts with definitions. If by Milky Way you mean the bright stellar disk, then the answer is easy, around 100,000 to 200,000 light-years across. That's the glowing band you see on summer nights, a flat pancake of stars and gas. But the disk isn't the whole story. Surrounding it is the stellar halo, a sphere of ancient stars and globular clusters that stretches hundreds of thousands of light-years farther. Do you count that as part of the galaxy? Historians still argue, because the halo doesn't have a sharp cutoff. It just fades into intergalactic space. Then there's the dark matter halo. If you include that, the Milky Way's edge balloons to over 1 million light-years, nearly halfway to Andromeda. Suddenly, our galaxy's border overlaps with its neighbours. Imagine two cities whose suburbs are so sprawling they merge. At what point does one end and the other begin? Some astronomers suggest the Milky Way and Andromeda are already touching, their halos tangled together long before the visible collision begins. And let's not forget the hot gas corona, that faint X-ray glowing bubble you floated through earlier. It stretches so far that even defining its outer limit is guesswork. Does the galaxy end where the gas density drops below a certain number? Or where the dark matter thins? Or do you call the edge the farthest star still gravitationally bound? Each definition gives you a different size. The Milky Way is either a modest disk, a sprawling halo, or a ballooned monster. Pick your favourite. A quirky tidbit, some astronomers have even coined a term, the virial radius, to help define the edge. It's a kind of compromise, describing the region where the galaxy's gravity dominates strongly enough to hold on to material. For the Milky Way, that's about 1 to 2 million light-years. But even that's fuzzy, because galaxies aren't cleanly isolated. They tug and are tugged by their neighbours. It's like trying to draw a circle around Earth's atmosphere. Does it end at the stratosphere, the thermosphere, or out at the tenuous exosphere blending into space? You float now at a supposed edge, but the stars don't stop. They just thin, fading into the darkness. You imagine standing on a hill at night, looking toward a city's glow. Up close, the lights are bright and obvious. Farther out, they scatter into the single bulbs, and eventually one last lonely porch light flickers in the countryside. Where's the edge of the city? That's the Milky Way. More porch lights scattered into the dark than anyone can count. Historians still debate whether it even makes sense to talk about the Milky Way's boundary at all. Some argue a galaxy is defined not by edges, but by relationships. What's bound to what orbits what belongs to which gravitational family. By that definition, the Milky Way ends wherever Andromeda's pull takes over. Others argue we should stick with what we can see, the bright disk you trace in the sky. Neither camp is wrong. The galaxy, it turns out, is too big and too fuzzy to be corralled by one tidy number. Here's a fringe tidbit to keep you awake tonight. The Gaia spacecraft has identified stars so far out in the halo that they're teetering on the brink of being unbound. Some are likely interlopers from other galaxies. Others are just barely hanging on, their orbits stretching hundreds of thousands of light-years. It's possible that the Milky Way's edge is dotted with stars in limbo, not sure whether they belong to us or to intergalactic space. Imagine being a star with dual citizenship, half in, half out. You linger here, letting the debate swirl. Is the Milky Way 100,000 light-years wide, or 1 million? Or does it have no true edge at all, just a gradual fade into the great cosmic sea? The more you think about it, the more comforting the ambiguity feels. The galaxy doesn't need to fit into a neat box. Its size is elastic, layered, contextual. It's both a city and a wilderness, both a disk and a halo, both visible and invisible. And maybe that's the point. The Milky Way isn't a single number. It's a story of expansion, of blurred edges, of boundaries dissolving into infinity. You drift a little farther, the faint stars thinning, and you realize something. Measuring the Milky Way has always been about more than just counting dots. Each generation of astronomers has needed new yardsticks, new ways to stretch their reach across the void. First it was eyeballing brightness. Then Cepheid variables came along, those pulsating stars that blinked out distances like Morse code. But now, in the 21st century, the toolkit has exploded. You're surrounded by cosmic rulers, pulsars, quasars, even gravitational waves, all whispering different measurements of our galaxy's size. Take pulsars, for instance. These are rapidly spinning neutron stars, the dense cores left after massive stars explode. They beam radio waves like lighthouse beams, sweeping Earth at clockwork precision. By timing their signals, astronomers can measure distances and motions with exquisite accuracy. Some pulsars scattered across the Milky Way act like GPS satellites, helping chart the galaxy's structure. You imagine drifting beside one, a city-sized sphere whirling dozens of times per second, its beams flicking across you like a strobe light. It feels less like a star and more like a machine ticking out the galaxy's dimensions. Then there are quasars, those blindingly bright hearts of distant galaxies powered by supermassive black holes. Astronomers use them as fixed background lighthouses. When gas in the Milky Way's halo absorbs some of their light, the absorption lines reveal the corona's makeup and reach. Suddenly, the galaxy's outermost layers can be probed, not by looking inward, but by peering through the galaxy at objects billions of light years away. Historians still argue whether this method provides a true measurement of the Milky Way's size, but it's one of the only ways to study its faintest outskirts. And then, of course, there are gravitational waves. These ripples in space-time detected for the first time in 2015 aren't just tools for studying distant black hole mergers. They also promise new ways to measure galactic distances. By comparing gravitational wave signals with electromagnetic light from the same event, astronomers can refine the cosmic distance ladder. Imagine stretching the Milky Way's edges not with light alone, but with the trembling of space-time itself. It's a ruler so strange and futuristic that Galileo would have laughed or fainted at the idea. Here's a quirky tidbit. Even gamma-ray bursts, those fleeting flashes of high-energy light, have been used as galactic yardsticks. Some bursts come from within the Milky Way, others from far beyond. By cataloguing them, astronomers can tease out the scale of the galaxy's energetic events and compare them with those in other systems. It's as though the Milky Way occasionally drops a firework, and by measuring the sparks, you can guess the size of the stage it's fired from. The debate over yardsticks isn't just about precision, it's about overlap. Parallax works for nearby stars, Cepheids for mid-range, Type A supernovae for galaxies beyond. Pulsars, quasars, and gravitational waves stretch the limits even further. Historians still argue whether one method will ever reign supreme, or if the truth will always come from weaving them together like threads in a cosmic net. You hover above this network of rulers, each one fragile alone but unbreakable when combined. A fringe note. Some astronomers are even experimenting with using fast radio bursts, mysterious millisecond-long blips of radio light as new distance probes. These signals are scattered by free electrons in the Milky Way's halo. By studying how much they're dispersed, researchers can measure the density of gas along the path, which in turn helps trace the halo's extent. Imagine a galaxy-wide ultrasound, the bursts pinging through gas to reveal hidden layers. You drift back, watching all these tools in action, and it feels like the galaxy is being measured from every angle, not just in visible light, but in radio waves, X-rays, gamma rays, gravitational tremors. Each one reveals a different piece of the puzzle. The Milky Way is no longer a blur of stars. It's a multi-wavelength, multi-messenger giant, mapped not by one ruler, but by an arsenal of cosmic yardsticks. And here's the best part. Every new tool pushes the galaxy's boundaries outward. The more precisely we measure, the bigger the Milky Way seems to grow. What once looked like 15,000 light-years across to Herschel now stretches 10 times farther, maybe more, depending on the halo and corona. The galaxy is like an elastic band, snapping wider with every new observation. And you, floating here in the silence, can feel that expansion in your bones. The Milky Way glows around you, no longer a blur of myth or a fuzzy map, but a galaxy defined by numbers, massive, sprawling and layered. After centuries of guessing, measuring and arguing, astronomers can finally give you some ballpark figures, though even now the ranges are wide enough to make your head spin. The current consensus: the Milky Way is about 100,000 to 200,000 light-years across, depending on how you define its edge. Its mass is somewhere around 1 trillion solar masses, and inside it, perhaps 200 to 400 billion stars burn, with planets numbering in the trillions. You can almost hear the galaxy sigh, "Yes, I'm huge, stop asking. Let's break that down." The disk, where most of the stars live, spans at least 100,000 light-years. That's the part you see in the night sky, the glowing river overhead. Add the faint stellar halo, and you're at 300,000 light-years or more. Include the dark matter halo, and the number leaps to 1 or 2 million light-years. That's big enough that the Milky Way and Andromeda's halos already overlap. Historians still argue whether that overlap counts as touching, or if the galaxies are still separate until their stars collide. But either way, the Milky Way's reach is enormous, bigger than Herschel, Shapley, or even Curtis dared to imagine. Inside this leviathan leave stars of every kind. The average is a humble red dwarf, faint and cool, making up the majority by number. Our sun, bright and yellow, is actually in the minority. Only about 7% of Milky Way stars are sun-like. Then there are the blue giants, or massive and short-lived, burning hot and dying young in brilliant supernovae. And somewhere out there, neutron stars and black holes pepper the disk and halo, remnants of lives lived fast and violent. Counting them all isn't possible, but surveys give us confidence that the Milky Way is home to at least 100 billion planets. Statistically, that means there are more planets than stars, and more than enough chances for life to exist elsewhere. A quirky tidbit: one recent estimate suggested that as many as 6 billion Earth-like planets may orbit Sun-like stars in the Milky Way. Imagine that, 6 billion rocky cousins scattered among the arms, each with the potential for oceans, atmospheres, maybe even strange forests or alien cities. Of course, no one has seen those worlds directly, but the math is tantalizing. It turns the Milky Way from a sterile city of stars into a galactic archipelago of possible homes. The galaxy's mass is harder to pin down than its diameter. Stars, gas and dust only account for about 15% of it. The rest, dark matter, remains elusive. Depending on which models you use, the total comes out somewhere between 800 billion and 1.5 trillion suns. That uncertainty doesn't mean astronomers are lost, it just reflects how complex the galaxy is, with its streams, halos and invisible scaffolding. Historians still debate whether future telescopes will ever narrow the range, or whether dark matter's mysteries will keep the Milky Way's true weight forever hazy. Still, even with the uncertainties, the numbers are staggering. 1 trillion suns worth of mass, hundreds of billions of stars, trillions of planets, a disk so wide that light itself takes 100,000 years to cross it, the halo ballooning so far that it almost brushes the next galaxy over. You stand in the middle of all this, a tiny passenger on a pale blue dot, and realize that the Milky Way is both home and wilderness, familiar in the constellations you trace, yet incomprehensibly vast in its full sprawl. Here's a fringe tidbit. Some astronomers propose that the Milky Way might host as many as 10,000 black holes clustered near the centre, their gravity tugging faintly on the stars around them. If true, that would make the galactic core an even stranger place than Sagittarius A alone suggests. The numbers keep multiplying, the possibilities spiralling, until your brain just laughs and gives up. How do you really picture 1 trillion suns, or 6 billion Earths? Or a halo so big it could swallow Andromeda's suburbs before lunch? You can't. You can only whisper the numbers like mantras and let the immensity wash over you. And maybe that's the quiet beauty of it. The Milky Way is finally a galaxy with numbers attached, but the numbers themselves are so huge they circle back around to poetry, 100,000 light-years wide, 1 trillion times the sun's mass, hundreds of billions of stars, trillions of worlds. You say the figures softly, like a lullaby, and feel the galaxy expand inside your imagination until it dwarfs even your wildest childhood dreams of space. You linger at the edge of thought. The Milky Way laid out in numbers and maps, but now the perspective shifts. Instead of seeing the galaxy as something abstract, light years, masses, and halos, you feel its scale pressing down on you personally. You, right here, in this swirl of stars. The immensity isn't distant, it's wrapped around you. Every breath you take is happening inside this colossal structure. Every heartbeat timed against a galactic clock. The Milky Way isn't just a scientific object, it's home, and that realization softens the math into something intimate. Picture your place. The Sun sits about 25,000 light-years from the center, tucked safely in the Orion Spur. That's a minor branch, a kind of cul-de-sac compared to the galaxy's grand avenues. If the Milky Way were a city, you'd be living in the suburbs, quiet, stable, far from the chaos of downtown. That suburban address is probably why Earth has managed to thrive without constant bombardment from supernovae or black hole flares, a galactic sweet spot. Historians still argue whether our specific position influenced the rise of complex life, but it's tempting to think our little corner was chosen by cosmic luck. The Orion Spur itself feels modest compared to the grander arms. The Sagittarius arm glows with star-forming regions like the Eagle Nebula and Lagoon Nebula, while the Perseus arm houses clusters and gas clouds sprawling farther than you can imagine. Yet even this minor spur is thousands of light-years long, and it's your address. Every star you see in the night sky with your naked eye, almost all of them live in this same spiral spur. That cozy sense of belonging, that's what anchors you when the galaxy's scale feels too overwhelming. A quirky tidbit, the Sun completes one orbit around the Milky Way roughly every 25 million years. That means the last time Earth was in its current position, dinosaurs were roaming Pangaea. Every lap around the galaxy is a cosmic era, and our species has existed for only a tiny fraction of one lap. When you look up at the Milky Way, you're not just seeing space, you're seeing the racetrack you and your ancestors have been riding all along. You let your eyes wander across the arms and halos and streams, and then you bring your attention back to your own body, sitting here on a planet that is both insignificant and extraordinary. The same laws of gravity that keep your feet planted to the ground are the ones tugging entire stars around Sagittarius A. The same atoms in your body, carbon, oxygen, iron, were forged in past generations of Milky Way stars, recycled into you through supernovae and stellar winds. You are, quite literally, part of the galaxy, not a tourist, a native. Historians still debate how much of the Milky Way's story is unique. Are most galaxies shaped like ours? Do they all have coronas, halos, streams of devoured neighbours? Or is the Milky Way an oddball in some way? The answer is still unfolding. But to you, it doesn't matter much. What matters is the feeling of lying back on a clear night, tracing the glowing band overhead, and knowing you live inside this thing. Every twinkle, every arc, every smear of light is part of your home address. Here's a fringe detail for you to savour as you drift off. Some astronomers have suggested that the very act of consciousness, our ability to look up and reflect on the Milky Way, might be as rare as any star cluster or nebula. Billions of stars, trillions of planets, yet here you are, aware of it, whispering its name. That awareness may be one of the rarest phenomena in the galaxy. And that thought, more than any number, makes the Milky Way feel both endless and intimate. So you sit quietly, imagining the disk stretched wide, the halo puffed out, the corona glowing faintly, the black hole anchoring it all. The Milky Way is vast beyond comprehension, 100,000 light-years, maybe 1,000,000 if you count the outskirts, but it is also the only galaxy you've ever called home. And no matter how big the universe is beyond it, this is the structure that has held you, fed you, and carried you on its slow orbit for billions of years. You're not outside it, trying to measure it. You're inside it, living it. And that's enough to make even the most overwhelming immensity feel like a lullaby.